Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics in the year 2021. The question is from the topic of rotational motion. The question is based on the marking scheme of integer type. So those who got this question right will get +4. Those who get this wrong will get 0 marks. The question is not very difficult, although some students would have gotten this wrong because of one particular error if they would have committed that. But apart from that, there's nothing difficult in this question. Okay, so basically there's a rod of mass m and length a which is rotating about this fixed axis with constant angular velocity capital omega. Now there's a disk which has been hinged on this rod, and this rotates about this axis, this axis at an angular velocity of 4 omega. Okay, about this axis. So we have to find the angular momentum about point O of the whole assembly. Okay, mass of both rod as well as disk is m, and this rotates with 4 omega about its center. Now those students who thought of this as a rigid body would have written simply I omega and would have gotten this question wrong. But this disk is not rigidly attached to rod. In fact, this disk is rotating at 4 omega about this axis. Okay, so let's write the angular momentum. Now if you just see the rod, so the angular momentum of the rod is I omega about this axis. I will be ma square by 3 into omega. Okay, and this will be in the anti-clockwise sense looking from the top. If you look from the top, then this will be omega square by 3 into omega. Okay, now we have to write the angular momentum of the disk about point O. Angular momentum of the disk about its center of mass will be I omega, where I will be the moment of inertia about the center of mass. Okay, plus angular momentum of center of mass about point O. This is what we are going to do, right? So m into a square. A is actually a by 4. Radius of the disk is a by 4. So m a square by 2. So I into omega, which is 4 omega. So this is the angular momentum of the disk about its center of mass, plus angular momentum of center of mass about point O. That is mvr. So mass of the disk is m. Velocity of center of mass will be 3a by 4 into omega, because center of mass will be going in a circular motion of 3a by 4 about point O with an angular velocity of omega. So 3a by 4 into omega. So mv into r. R again is 3a by 4. So we can add this up. So we can see that ma square omega will come out to be constant. Here 1 by 3 will remain. Here we will get 1 by 16 into 4 is 1 by 4 plus, and half was also there, so 1 by 8. Here we will get 3 is 9 by 16. Okay, so if you take the LCM, what do we get? 48 will be the LCM, and this will be 16, this will be 6, and this will be here 27. So this will become ma square omega into 49 upon 48. So if you compare this with the given expression, so n will come out to be 49. So 49 should be the correct answer for this question. So simple question. As I said, those students who thought that this is a rigid body would have gotten this wrong. Otherwise, this was a fairly regular question. That's it. Thank you.